You already know some types of numbers, say natural numbers, 1, 2, 3, 4, 5, 6, 7, 8 and so on. These are called natural numbers. There is no zero, there are no decimals, 1, 2, 3, 4 and so on. There are no negatives also. Next series is whole number series, which includes 0 besides all numbers that are called natural numbers. So whole numbers means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. These things are also called sets. So when we say set, natural number set, then it means 1, 2, 3, 4 and so on. Whole number set means 0, 1, 2, 3 and so on. Various numbers lying within the set are called elements. So number 3 is the element of a set. By the way, number 3 belongs to natural number set also. It belongs to whole number set also. There are many such numbers that belong to multiple sets. After natural numbers and whole numbers, the next is integers. Integers means you can go towards the negative side also. So -1, -2, -3, -4 and so on. Also. So integers will include all whole numbers and minus side also, -1, -2, -3 and so on. But there are no decimals in integers. Next we have the concept of number line. A line like this is called number line, in which various numbers are indicated. Various numbers are indicated. So 0 suppose is here, then 1 will be here, 2 will be here, 3 will be here, and likewise -1, -2, -3. It will go on and on in both directions to represent 4, 5, 6 or -4, -5, -6. That is number line. Distance between these points must be same as distance between 2 points. Any 2 consecutive points must be equidistant if you are representing integers. Then anybody looking at this line would wonder, what about this region? There are so many points in this region. Are we missing something? Yes, we are missing. So we need to discuss further. So natural numbers, whole numbers, integers. Further, rational numbers. What are rational numbers? One integer divided by another integer, but you can't divide by 0. Dividing by 0 is a very bad idea. So one integer divided by another integer, where the denominator is not 0. This type of number is called rational number. These fellows give rise to decimal and can take number of positions in this region or in this region or in this region or in this region. Note that between 0 and 1 there are infinite points. There are infinite dots you can make. Infinite. So there are large number of rational numbers here, 0 to 1, in between 0 to 1, between -1 to -2 and so on. Now, if q is 1, then any rational number is p. If q is 1, and we said the p is an integer, q is an integer. So if q is 1, then the rational number is p, and p is an integer. So every integer is a rational number. Every integer is a rational number also. Every natural number is a whole number. Every whole number is an integer. Every integer is a rational number. Now there can be some interesting situations when we talk about rational numbers. P and Q we say are integers. How about 2 and 4? How about P equal to 4 and Q equal to 8? How about Q equal to 8? How about P equal to 8 and Q equal to 16? You will find that 2 by 4 is same as 1 by 2. 4 by 8 is same as 1 by 2. 8 by 16 is same as 1 by 2. It happens with several rational numbers that they are all same. Such rational numbers are called equivalent rational numbers. Such rational numbers are called equivalent rational numbers. So one would naturally think that why not make it simplest? Why write 8 by 16 if you can write it as 1 by 2? So we have a concept called simplest form of a rational number. Simplest form of a rational number. If P and Q have no common factors, you cannot cancel anything else. And of course, Q cannot be 0. Q cannot be 0. Then you have got the simplest form of rational number. So many times you would be given some other form which is not simplest form. You cancel as many factors as you can. Whatever is left, like 1 by 2, how can it be simplified further? Integer, integer. It has to be integer upon integer. But in the simplest form, you can't have further common factors in numerator and denominator. Can you tell me what is the simplest form of 6 by 9?
2 by 3. 2 by 3. 2 by...
Two by 3. Let's make it a little more difficult. What is the simplest form of 95 by 133?
5 by 7.
5 by 7. Any problem? Let me know. Now we can fill many places. If you got only integers, many places remain unfilled. But now you can fill many places. Say this is of 1 unit length. 1 unit length, 0 to 1. Let me draw here. One unit length. Midpoint of it will be half. This is 1 unit. But 1 can be written as 2 by 2 also. So 2 by 2 is basically two parts of this piece. This piece called half is taken 2 times. You can take that piece called half 3 times, 3 by 2, 4 times, 4 by 2, 5 times, 5 by 2. So one piece called half can be taken 2 times, 3 times, 4 times, 5 times, minus 1 time, minus 2 time, minus 3 time, minus 4 time, and so on. 3 by 2 is 1.5. It was not there earlier. 5 by 2 is 2.5. It was not there earlier. So many points that were not marked, now we can mark them. This is 0.5, 1.5, and so on. So decimal comes into picture when we talk about rational numbers. It is needless to say that distance should be same. When we say this is half, half more, they all must be equidistant. This equal to this, equal to this. Now we took one unit first, 0 to 1, we divided into 2. We can also do something else. Say this is 0, this is 1. We divide it into 3 pieces. Each piece is called 1 by 3. Double of that, 3 times of that, 4 times of that, 5 times of that, and so on. And likewise, we can go to the left side. So many points you can mark now on the number line, which you could not mark earlier when we were talking about natural numbers, whole numbers, and integers. Now, how would you mark something like 2, 3 by 8? 2, 3 by 8 is basically a way of writing 2 plus 3 by 8. They are identical. So how would I mark it? Suppose this is 0, this is 1, this is 2, this is 3. I know I want more than 2. So obviously I will come up to this point. Then I'm searching for 3 by 8. 3 by 8. I will divide this into 8 pieces. This from here to here, this line segment I will divide into 8 pieces. 2 pieces. Now how many? 4. We got 8 pieces, right? 8 pieces. So 2 plus 3 by 8, this one. That is 2 plus 3 by 8 or 2, 3 by 8. This point. Any questions? Let me know. I will give another illustration for the negative side. What is the meaning of minus 1 5 by 7? 1 5 by 7 means 1 plus 5 by 7. That is 1 5 by 7. There is a minus sign outside. So it means minus 1 minus 5 by 7. Number line 0, minus 1, minus 2, I don't think I need to go further than that. Now minus 1 I have already arrived. Now I am searching for minus 5 by 7. I divide this line segment of 1 unit into 7 parts. I would need to do some approximation now. Seven parts. Then I have to pick up the fifth. That one is the answer. Any questions? Let me know. Now, can you represent number 5 on the number line? Represent number 5 on the number line. You can use the board if you want. Yes. That's it. Now, next. Can you represent 5 by 7 on the number line? You can use the board if you want. This one is going between 1 and 2, not correct. This one, what is that? I think this is done. This one is okay. 1, 2, 3, 4, 5th. This should be 7. Yes. So anybody has any questions, let me know. This one is right. All right. I'm moving on. Now try 1.3. You can use the board if you want. No, this is not correct. This is 1.2. This is 1.2, not 1.3. You should pick up this one. And then why have you shown so little gap here between 0 and 1 and such a large gap between 1 and 2? Now you can use typing. Look at this in writing. You can improve that. You will see some way of typing there. It's very easy. You can type out. Okay, I think I will look at the absolute bottom one. 3. Yes, this one is okay. This one. 0, 1, 2, 3. Alright, look at the absolute bottom one and we move on. So the basic idea was that 0.3 is 3 by 10. So you have 10 gradations and you pick up the third one in that. Any questions? Let me know. Look at the bottom one and if you have any questions, let me know. Now try this. You can use the board if you want. 23 by 6. Okay, I can see some improvements in the quality of the work. That's good. You can carry on. 23 by 6 is basically 18 plus 5 by 6, which is 3 plus 5 by 6. 1, 2, 3, 4. How many parts? 1, 2, 3, No, this is not correct. Fifth part you have to pick up. Let's see this one, lower one. 1, 2, 3. Then 6 parts. Yes. This one is correct. Even the bottom one is looking correct. So any questions? If you have, then let me know. Now you must have realized that rational number lies between two consecutive integers. In fact, many rational numbers lie between two consecutive integers. Suppose I divide it into 10 parts, 0.1, 0.2, 0.3, all are rational numbers. If I divide it into 2 parts, I will get 0.5. One can get as many rational numbers as one wants. If I divide it into 20 parts, or if I divide this line segment into 100 parts, or 1000 parts, I can basically have as many rational numbers as I want. I can divide that in 1 million or 1 billion parts. How does one insert a rational number between two such numbers? Well, there are so many techniques. How does one insert one rational number? Well, one will say 0.5, that is correct. Other person can say 0.1, which is also correct. So if you are given the freedom to insert any one rational number between 0 to 1, well, you can give so many different answers and they all may be correct. 0.9 is correct. One common practice we follow is that we take the average. If you want to insert one rational number between two integers x and y, then we take the middle one. That's a common practice. If you want to insert only one fellow, only one rational number, what if we want to insert more? Suppose I want to insert two numbers. Now I can take them equidistant, which is correct, but I don't have to take them equidistant also. I can take one here, another one here. But generally we follow the equidistant approach. And how do we find such equidistant rational numbers? We find the distance between these two, which is y minus x. I'm assuming that y is more than x. So we find y minus x. If I want to insert two rational numbers, I will divide this line segment of y minus x length into 3 pieces, 3 parts. So I will find y minus x by 3. I will call that thing as D. This is D, this is D, this is D. D, D, D. So if this is x, that point will be x plus D. First rational number. X plus D plus D. X plus 2D. That is the second rational number. That's it. So if you want to locate or point two rational numbers, you will divide by 3. Y minus x will be divided by 3. So what if I want to insert n rational numbers? If I want to insert n rational numbers, I will find y minus x by n plus 1. If 2 numbers were there, 3 was there. If n numbers are there, n plus 1 will be there. That is what I will call as d. Then x plus d, x plus 2d, x plus 3d. And that way I will be able to insert n rational numbers, and that will be equidistant rational numbers. Now that, as I said, doesn't have to be the only approach. If the idea is just to insert 2, 3 rational numbers, different people can give different answers and all may be correct answers. This is just one approach which gives you the equidistant rational numbers. I will give you illustration. And by the way, you can insert rational number between 2 rational numbers also. Suppose between 0.2 and 0.4, I want to insert one rational number. Then one common sense answer will be 0.3. There can be another answer, 0.25, several answers. So what we have discussed, the procedure that works for x and y being integers or they being even rational numbers also. Let's say one rational number has to be located between these two. Done. Now, how about inserting more? So let's say between 3 and 4, we want to insert 6 rational numbers. No problem. If you want to insert 6 rational numbers, then the difference between these should be divided in 7 parts. 4 minus 3 should be divided in 7 parts. Call one part as D. So clearly D is 1 by 7. So x plus D, x plus 2D, x plus 3D, x plus 4D, x plus 5D, x plus 6D will be 6 rational numbers. So 3 plus 1 by 7, 3 plus 2 by 7, and so on and so forth. Can you finish these 6 numbers and tell me what values you are getting for these 6?
Sir, 3 1 by 7, 3 2 by 7, 3 3 by 7, 3 4 by 7, 3 5 by 7, 3 6 by 7.
Can't you simplify? For example, this one will be 21 plus 1, 22. Like that, can you simplify others also?
Sir, 23 by 7, 24 by 7, 25 by 7, 26 by 7.
I hope others are also getting the same. Very well. Any questions? Let me know. 22 by 7 may remind you of pi. But 22 by 7 is a rational number, as you can see. Is pi rational number? No. No, pi is not rational number. Then why do they tell you that pi is 22 by 7 if pi is not a rational number?
So it can be expressed in the form of 3 by 3.
Sir, approximate
Because
value.
approximate value. Yes, exactly. 22 by 7 is just the approximate value of pi. Pi is not equal to 22 by 7. We will talk about pi when we talk about irrational numbers. Right now we are talking about rational numbers. So I have given you illustration for both cases, simple case inserting one only and a more difficult case inserting many. Any questions regarding that? Let me know. Alright, so I'm going to give you something to try out.
Hello, sir.
Yes, go ahead.
We are approaching this method only as a convenient use, or is it necessary that it should always be done?
Can you repeat?
Is it necessary that we always have to do this method, or will it be specified?
It is not necessary. It is not necessary for you to use this method only. If I were to introduce 6 rational numbers between 3 and 4, I would not do all that. I would say one answer is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. Done.
Yes, sir. Thank you.
Now, three by 5 and 4 by 5. Insert 5 rational numbers.
Sir, 31 by 50, 32 by 50, 33 by 50,
And let's
see 34 by 50,
yes,
and 35 by 50.
I will have to check. From where did you start? 30?
31 by 50.
31. Okay. So you started from 31 and then you might have gone up to 35.
Hello? 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30, 24 by 30.
You started from 19.
Yes, sir.
Okay. Let's see. This one is correct. And the approach he has followed is, 3 by 5 can be written as 30 by 50. 4 by 5 can be written as 40 by 50. So obviously, all these 5 will be lying in between these. That's a good method. Then this approach, what approach have you followed to answer 19 by 30?
No, I multiplied it by 6 just to get a closer answer actually.
Okay. You multiplied by 6. Fine. So by 30, yes. 6 in 4, 24 by 30, yes. So this is also perfect. 19 by 30 and so on. 19 by 30, 20 by 30, 21 by 30 and so on. There can be various approaches. Any questions? Let me know. This is your assignment question. We stop now.